anyway. To tell you a little bit about myself, so I run sales at Loom Systems, and as Dave mentioned, Dave, thank you for having me. We do AI for IT. I'm going to talk more about that, but I'm not really going to talk about the product tonight. That's not interesting to you guys. It's more about what's happening in the industry and how to solve the problems that you guys face. Before I was at Loom Systems, I was at another predictive analytics company that predicted sales and marketing success using a ton of endpoints and pattern recognition and predictive analytics in that way. Before that, I got my start in my career as an investment analyst. So I was doing models that would predict which stocks and which sectors would perform best in certain types of markets and take into account a lot of data. So a lot of that analysis was done in Excel. So I have a special appreciation for working with difficult tools that don't do what you want them to do all of the time. But one of the things that I've been in this industry only for a couple months, I'm new to it, I'm an outsider. As I said, I'm into predictive and I'm into data. And one of the things I've noticed is that you guys have a really hard job. And this group, the developers, the operations analysts, you have a really difficult task in front of you every single day, and you're under the microscope and you're under a lot of pressure to get the job done. So I can appreciate that, and that really formed the basis of the talk that I put together tonight. I want to make the assertion tonight that you guys are asked to do things that human beings are just not wired and not built to do every single day and for 10 hours a day. And that the only way that you're going to be successful is if you get a little bit of help from robots and from artificial intelligence. I'm not recommending that we all be replaced by robots. That'll never work, and it's impractical, and it's not my message. But you guys can be helped with some artificial intelligence to be more effective, and for your businesses to find problems in your IT stack, resolve them faster, and that helps the business. So that's what my talk's going to be about tonight. And as you guys noticed from the invite, the subtitle of the talk is Fighting the Last War. And we've all heard this term, and I had heard it, but I didn't know where it came from, so I did a little bit of research. And it really came to prominence in the early 20th century, and especially around the time between the First and Second World War. And at this time, France was doing something. They were building what's called the Maginot Line. And I see a couple head nods, that's cool. Maginot, okay. Oh, oui. Okay. So what they did in World War I, it was really effective to build trenches and to have heavily fortified barracks so that you could fend off slow-moving hand-to-hand armies. And since that worked in World War I, when France saw an impending threat from Germany, which is right across the border here, they thought, okay, well, we're going to take that approach, and we're going to build up some fortification from Germany, because Germany looks pretty scary right now. They're doing some weird things. What they didn't do was fortify the border with Belgium, because Belgium was kind of neutral and they weren't a real threat at the time, and they saw what worked in the last war and they responded accordingly. When Germany decided that they wanted to invade France, all they did, you guys can kind of probably guess here, they marched around and they invaded Belgium and they came in through France where it was unfortified. So we as human beings have this tendency to prepare for what has happened and not look forward to prepare for what might happen. And that's only one of the ways that our brain can work against us, and that us as human beings can be unprepared for the jobs that we have to do, which I mentioned I think are really hard, and you guys all know. So I'm going to talk about other examples of this, and then recommend a solution on how robots and human beings can work together. And Dror's going to show some real life examples that come right from your world of artificial intelligence helping to get to that problem resolution faster. Couple quick notes. So the bottlenecks in the industry have totally changed right now. In the last decade, in the 2000s, difficulties were around storing data, querying it, and processing it. because there's so much data and it was growing at a certain rate and that was a real bottleneck. Well, that's all been solved. And it's solved pretty cheaply now. And today the big bottleneck is data scientists. And data scientists are in this room. They are SREs, they're DevOps engineers, they're IT analysts. And Harvard Business Review calls this the sexiest job of the 21st century. So who has a job that kind of fits in this category? Anybody? Anybody? Who's sexy? Come on. You guys are sexy. This is the sexiest job of the 21st century. And by sexy, it means that you guys are in really high demand. And it's because businesses can't solve these problems. There's not enough of you, there's not enough talented people that they can just throw extra bodies at it. There has to be something more, and that's where artificial intelligence comes in. To go a little further, businesses are really struggling right now to capture value from their machine data. Machines are producing more data than ever. You guys know, you've heard a lot of those statistics, but the amount of investment that companies are making in tools to either understand their data or to monitor, in a lot of cases in this room, businesses aren't getting the value that they're investing in those tools. It's a real challenge, and it's a very common challenge, and one that represents, according to some sources, a $20 billion market for tools that can solve this. To scale that for you, $20 billion is roughly the size of the CRM market. So most companies have CRMs. This is as big of a potential market as that. So let's talk about a couple things that humans are good at and that robots are good at, because they're different. We'll start with robots. So robots, or machines, are good at recognizing patterns. They are good at working within strict methodologies, very large numbers and large dimensionality, trend detection, picking up on trends in real time, and then also working with systems that are complex. And IT systems would tend to be complex. Humans are very different. So while robots are excellent at the defined and bottom-up tasks that are really at the detailed granular level, human beings are good at the top-down tasks. So this would be something that requires a lot of reasoning or a lot of contextual thinking, such as our business has 10 locations. Where should we open up an 11th one? Right? Open-ended. You could go anywhere with it. Human beings are good at this because we deal with it every single day, and it's an evolutionary thing. Downsides of human beings: they get tired, they get bored, frustrated, and are sometimes married. Right? So let's talk about each of those examples. And I'm going to go through a few examples of these areas where robots are really good, and we'll see maybe if the human beings in this room are just as good as the robots. So let's read this slide, and I want anybody in the room to just yell out, what's the mistake? Who is it? Who is it? Okay, read it for me.
Can you find the mistake?
Who saw it? Did anybody miss it? Anybody shy, or anybody bold enough to admit that they missed, that it's not in the different colored numbers? So this is something called priming. And if you prime a brain to think in a certain way, or subliminal messaging is what they used to call this in like the 50s and 60s. If you prime somebody to think in a certain way, such as patterns, if you look at a pattern here, you're going to look at the numbers, you're going to look at the colors first, you're going to ignore one of the things that I just mentioned, which is strict methodology, such as spelling and grammar. A machine would find this immediately 100% of the time. Never a doubt. But a human being can miss it because we're just built different. We're built to solve real world problems, not figure out how many times a certain word appears in front of us. Okay, so let's keep going. Now let's talk a little bit about large dimensionality. And the reason why this is important is because data grows and grows and grows, and I don't think there's anybody in this room who thinks it's going to slow down. So the petabyte is the new terabyte. It was only a few years ago that we talked about terabytes, and that was big. Now Facebook produces 500 terabytes a day, so it takes them 2 days to produce a petabyte of data. That is, I can't use the word I want to describe to say how much data that is, but it's a lot. And then if you look at just how much data is growing, it doubles every single month. So there's 2.5 exabytes of data that are created in aggregate every single day. and it's doubling every single month. And I think that's just really shocking that the rate is not just growing, but accelerating. So how fast data is growing is only going to get harder and harder. And the reason why that's relevant to us in this room is because our ability to analyze it, our ability to make smart decisions based on that data is not growing as fast as this. It is getting away from us and is getting to be a bigger and bigger problem every single day. So let's do some things with large dimensionality here. So let's just talk about $1 trillion, and let's talk about $1 trillion. How much is $1 trillion? I'd like anybody out there to just try to describe to me how much $1 trillion is.
Hundreds.
It's what?
Truckload of hundreds.
Interesting that you went that direction. I heard truckload of hundreds. Okay, cool. Any other answers? Yeah. Okay, I like where you're going with that too. Did you guys see my presentation before? Have we met before? Okay, so really interesting that you said that. So if you took $100 bills and you stacked them 7 feet high, I'm 6'4", so that's 8 inches higher than me. So it's right up here. If you stacked $100 bills 7 feet high, they would cover an area that's 2.2 acres. Okay, football field's about 1.3 acres, so this is almost 2 football fields of $100 bills. So human beings are not good at this. You said a truckload, that's a great answer. A train, right. Yeah. But so let's think about that though. A truckload versus a train load. To human beings, like, well, that's a lot. Both of them are a lot. Those are very, very similar. But in your world, if you're off by that amount, that can have grave repercussions on the business, especially when you're trying to prioritize which issues are most important to solve first. And then secondly, especially if some of you guys live in logs, do a lot of people do some log analysis in the room? Yeah, of course, right? So these things are coming in at hundreds or thousands per second. You are literally looking for a needle within football fields. It's no longer a haystack. And if you can have some tool and it can just bring you, instead of to the thousands of haystacks that you have to look in, into the most probable ones, that's a huge jump and that's a huge increase in effectiveness. So large dimensionality is hard for human beings, very easy for robots. Another concept here is that things are constantly changing in your world. So what is the furthest planet away from the sun in the solar system?
Saturn?
Okay, interesting answer. What else?
Pluto.
Uranus, okay. This is real. I've heard 5 different answers. I heard Uranus, which somebody said just to be funny. I heard Pluto, and I heard that there's some switching off that's happening. The answer? Neptune is the furthest planet away from the sun in the universe, in the solar system. Okay. There's 8 planets in the solar system, and the reason why I bring this up is because it's changing. When I was a kid, I was told there were 9 planets, and I was told that Pluto was the furthest one away. But over time, there's been as many as 23 planets. There were, yes, exactly. So as you can see here, in 1781, the person who said Uranus would have been correct, that Uranus would have been the furthest one away. So there were 6 planets at that time. There were 7 shortly after, with a bunch of asteroids and moons were considered planets. And then sometime around 1850, they said, okay, asteroids are no longer planets. They cut it down to 8, and then they discovered Pluto, it became 9. And then in 2006, they demoted Pluto. Now it's a dwarf planet. So now there's 8 planets in the solar system. If you'd asked me in 2006, are there 9 planets and is Pluto the furthest one away from the sun? I would have said absolutely yes, and I would have bet my house on it. And I'd have been dead wrong, because the rules are changing. And this is very similar to your guys' lives, in that your IT systems are constantly changing. And I've been on the wrong end of this before, so I'll apologize to anybody that's had this happen. But have you ever had a sales leader that decides he wants to go out and trial a new piece of software without sort of notifying anybody in operations or in monitoring, and then it causes problems and has impacts on other parts of the system? Well, that was me once, and it was a huge issue, and I had to spend a lot of time, and our company had to spend a lot of time unwinding it. So things are constantly changing, and you're not not usually the first people to know. You have to pick it up, and you have to have a system that can help you adapt. You have to have a mindset and a way to keep up with things that are changing. Okay, so let's keep going here. I said it came from the financial world. I'm gonna ask you guys, which of these stocks would you buy? Here's one, and here's two. Who would buy the first one? Okay. Who would buy the second one? This, I love this group. That is the answer, right? This is the same stock. This is General Electric, good old General Electric. One of our country's original, just tried and true blue chip stocks. And in 2008, it did this. It lost about 2/3 of its value.
I'll buy it then.
After this, you would love to do that, right? Except your brain would be working against you at that
The
point.
point, your question is correct, because when you say who would buy that, it assumes who would buy that at that point. So I think buying it at the low, I think it's a good idea, right?
I think next time we do this, we're going to do it together. You and I are a good pair, because that's exactly true, right? It's only important in a complex system, which we deal with every single day. A question is only important in context. So would you buy this? Or a question like, would you buy General Electric? You can't give an answer to because you don't have enough information. And if you don't have enough information, you're prone to error. And that happens to us all the time, because if you're only looking at one small piece, if you're working on your applications and you don't know how they're interdependent on things like your servers or things like your middleware, you can make some grave errors by only seeing what's in front of you and not considering the rest of the information. So let's start to kind of marry this together, because there is a solution. I don't mean to just sort of give you guys bad news all day. Robots can help with this, machines can help, and we can work together better. So if we believe that the only way to make good decisions is to have context and to have the full information behind the questions that you're trying to answer, then let's illustrate how we can start to make better decisions. So 50 trillion or 18.4 trillion, I'm not gonna ask the group. 50 trillion is bigger than 18.4 trillion. But it really depends again on the question. So 50 trillion.
You want to give us 50 trillion?
I might.
Are you bringing the money up?
50 trillion. Hold on. It's a patient group, I appreciate that. Is what this note says on it. It's 50 trillion Zimbabwe dollars.
Oh, that's cool.
Okay?
Oh, God.
That's a cool bill.
So this is one of my favorite souvenirs from all my travels around the world. I picked it up after a period of hyperinflation when these poor people in the country had to count, it has 13 zeros after the 5 on it. Like, what if somebody says, pay me 10 trillion and I'll give you 5 back, and they're like, oh, I just have all these 10 millions, what do I even do? It was not even worth the value. It wasn't worth the paper it was printed on. It's still not. It's worth a little bit. And then 18.4 trillion, our friend right here is very close. So this is the annual US GDP. So if you have a way to get all of the information, you can make good decisions. So clearly 18.4 trillion is more than the money I just put into my pocket. I would have better security around here. So correct decisions are only possible when you consider the full picture and all of the information around the question that you're trying to answer. So let's apply this a little bit more to IT monitoring and resolution. So before AI, all of you as human analysts had to define what to monitor. So you had to think about, okay, what negative scenario could happen so that I could go in and set an alert for it. And then if it happens, I'm going to be notified, and then I can go in and fix it. With AI, you don't have to, you're not reliant on thinking through that negative scenario, because you can measure everything. There's no capacity constraints. You can literally you can literally troubleshoot for every possible scenario rather than thinking through the ones that only you come up with. And then in terms of the data, there's a lot of effort that goes into preparing the data. Jor's going to show us a couple examples of how this is solved. That's not necessary if you have a proper AI tool, because it can auto-structure and not require the configuration from you. You, before AI, need to search for issues. With AI, you can employ a cognitive reasoning engine to think through in the way that you would the most common, the best suspects of what might be going wrong, and shortcut the process to increase your probability of solving it faster. Before AI, you need to analyze and correlate things yourself. With AI, you can automate the root cause analysis because it's all sequences. And if you can identify how the sequences occurred and what negative event precipitated the next one, and how the rest of the dominoes fell after that, you can go back to the first event and you can identify it as a root cause. Before AI, you have to seek solutions. With AI, they can be pushed to you, and then with AI, you're built for scale. So I'm making some pretty bold claims here, and I know that. I'm sure that you guys are skeptical, and maybe you'd like to feel like this, but you're not really convinced, and that's totally normal. And know that everybody has been skeptical of self-driving cars for 50 years, and people have talked about that for 50 years. Does anybody really think that self-driving cars won't work?
Yes.
Okay.
It will work technically, but there are a whole bunch of other problems.
Ethically,
Okay.
ethically it won't work.
What's ethical?
Ethically, okay, so ethically is an excellent point.
Ethically, legally, many
Yes.
other things.
There are plenty of challenges here, but what has been proven is that it is technically now possible. And if you extrapolate the success that has happened recently, you can see that this is on a track towards success. But that's only been recently. And the changes recently are not as a result of street signs being different or roads being now configured in an easy way, or even cars changing that much. Cars have 4 wheels and a steering wheel and then seats, and they haven't changed that much either. What's changed is AI. And artificial intelligence is now reaching the level where things like this are possible. And now that's also why artificial intelligence can impact your guys' lives and help make you more effective as well. So with that, I think, Dror, you want to grab the Britney Spears microphone and show a couple real life examples?
Yeah. We're standing right.
I mean,
Okay, let's do it very fast.
This is the reverse Polish joke, or it takes
9 minutes, okay. Hi everyone. I'm Dror. This is D-R-O-R. Difficult name to spell, so I used to give you the full letters. I'm the product manager at Loom Systems. I come from a background of, I've been working for a big data, a social media company for 3 years, 5 years ago. And 2 years ago around, we founded Loom Systems, which is, we brought all our dreams to the table. And we're not going to talk about the company, we talk about nice examples of how can we apply AI to our daily work. The thing I want to say is that I came from the world of intelligence, and we've been developing for years using technology that allows us to extract insights out of big data in places where there's limited manpower. So we thought of, can we utilize the same approaches back in the army in the commercial sector and take advantage of it? And this is basically what we're trying to do. We try to build the software that extract these insights automatically. So looking on John's point before that, he talked about many things that the robot can do, and how can we mimic the work of a human being by building a robot. And we need to, let's assume we're trying to build a system that analyzes machine data as an input and trying to figure out what's going on. But the context is IT, or application monitoring. So you want to know what's going on in terms of the stability of the application and what's the status of it. So the first phase is about structuring the data, as John said. So here's an example of, let's assume I'm getting this stream of data. The problem I'm facing, you see the raw input sample, this is how my logs data looks like in real life. This is an example from Fortinet. So the raw data, just ignore the fact that it's moving, I'm going to refer to it in a second. The raw data looks like this, so the first challenge is structuring it. You have to structure the data if you want to analyze it. And today what you do usually is you look on this and you start to figure out, how do I parse it? How do I structure that part? And this is a very tedious process. Whatever tool you're using, you still need to have a look at this and think for yourself. And how do human beings doing it? You look at the fields and you start to figure out, okay, these are words or characters separated by white space, or sometimes there's a delimiter going on there. And you apply some reasoning around that, and then you think, okay, I want to catch that part and not the other part. So that kind of thinking is what leads you in the process of parsing. Now the system today is actually trying to do the same thing. It looks on the data, and the first part is about breaking it automatically into key and values, because this is the easier way to read it, is like when it's all structured. And then it needs to apply a different type of intelligence around understanding what is the host and what is the severity and what is the message, and all the rest are just properties of interest. So it looks for the data and the metadata, and the way it does it, it's an ensemble of algorithms that each one of them is actually looking for specific things that are of interest. For example, you all know that, let's say, severity can be 5 or 10 words, or sometimes it's code, but it's always like info and error and exception, and you can look for, or fatal, and you can look for these specific words if you want to classify them automatically. So you can build something that really takes raw input samples and understand the structure of them with limited human touch. And again, this is not perfect because we're trying to build robot here, and sometimes some cases are really complex. Like we have a customer in China, for example, they had these log lines in Chinese, and it was very difficult for us because all the logic didn't work at first. But now, so there's a place where you can always add your own. You need to have some aspect of flexibility, and to let the DevOps engineer to add his own JavaScript to do the manipulation, and we respect that. So we try to take you half the way and let you do some specific manipulations if you want after that. So just to wrap up that part, the system can today apply methodologies to structure the data and save you time doing this tedious process of pre-processing and parsing and so on and so forth. So let's say I structured the data already, and now I have a stream that is structured, it's ready for analysis. The second thing that John described before is cognitive reasoning. What the hell is cognitive reasoning? So cognitive reasoning is a fancy word that we use to say that the machine can detect meaningful issues in the data with zero configuration on your end. You don't have to define the threshold. You don't have to know what's interesting. You just let the software find it for you. And how can it help you? How can we do that? So the first part is every type of metric that you've seen before in the previous screen needs to be classified and needs to be measured accordingly. So let's say if you want to count the number of log lines, we call it meter. So it's just you count the number of instances of any log line. But let's say you have a specific number within it, like a CPU. So it's 80, 81, 82, 81, 82. You have to look on the value of the number. So that's a different measurement method. We refer to it as gauge. And the robot needs to figure out how he needs to monitor each and every metric and classify it accordingly. So there are algorithms that helps us classify the data and to apply the relevant measurement for any type of metric. After you classify all the metrics, then you can apply some statistics. And this is basically today it's part of a commodity. If you say anomaly detection, all of you probably know and familiar with these type of techniques. Usually they use only statistic behavior. They see when the spikes goes up or when the signal goes up or down. And that's pretty easy. I mean, it's not easy, but it's commodity. So looking on, you don't really see the screen. Okay, so let's try. Oh yeah, I need to open let's do this. I want to show you some nice examples. So when you say statistical anomaly detection, it's actually looking on signals and how to behave. Just a second, like this. Should work now. But I'm going to talk until John from the IT will help me.
Exactly.
Because it's predictive IT. I predicted it.
Yeah. John, we need some predictive IT here.
I don't know, let's just do reset. It always helps. Okay, cool. Okay, there you go. Okay, cool. So, here's the thing. These are anomalies. You see the statistical behavior and say, yeah, I know, it's spiking. We all know that. But the most important thing for you to understand is that you want to look at the data as human beings. And it's not always the statistical behavior that is interesting, but sometimes you need to look for the data itself, the content. For example, you want to look for specific keywords within the data, because this is how DevOps engineer works. When something goes wrong, you go to the logs, you try to look for bad things that happen, not only in terms of the volume of events, but also the keywords themselves. So you look for errors and exception and invalid and bad username, whatever string you're looking for. So So you want a robot to scan these bad words and to highlight in places where they are meaningful and they deviate from the normal activities. So you need to use statistical analysis and also content-based analysis. More than this, and this is my presentation. Oh, it's not working on both sides. Okay, so you apply statistics, you apply lexical capabilities, now you have a robot that detects meaningful issues in your data. What's happened next? I mean, how do you find, so you detect the signal, but now you start to do the root cause analysis. And root cause analysis is actually, if you use some kind of a tool, like, do you have log management tools here in JFrog? Do you maybe use Elastic or you bought some kind of a tool? Most of the tools looks like this. They let you see the data and scans it across the time, and they let you do some searches on top of it, which is great. But still, when something goes wrong, your engineer starts to triage it in real time, and it's a very tedious task to do. You need to search something, and you see results coming from all across the areas. And how do you get the insights out of it? What do you do with it? And this is the root cause analysis process. As my friend defined it, root cause analysis is the process of understanding that the kids are fighting, not because John pushed Sarah and she pushed him back, but because they are hungry. And this is your goal. I mean, you want to find what's going on in the data and the answer. So for that, you need to apply different type of tools. And you can say, you know, I have Splunk, I'm perfectly fine with that. And we just before the presentation, we searched for the Splunk cheat sheet, and you have like 6 pages long of a cheat sheet that explains you how you do the analysis. So it's a very difficult thing to do using these tools. So going back to the robot, what you wanted to do is that you want to have some kind of tool that to aggregate everything for you and to correlate them in one area. And how you do this correlation? First of all, time. You will look on things that happen on the same time, the same time window, which is logically makes sense. But you also look to the content itself. You look for similarity of entities. For example, I want to know what's going on in that time frame. So I'm looking, okay, here's something going on and here's another thing. But then you look for the specific IP address, if it goes back in the same areas, or if it's specific username or specific host. You apply you look for these specific entities because these are the things that are interesting you. So you want to use a software that also correlate things based on time and similarity of entities. And after that, you also want to apply metadata analysis around it. For example, you want to scan what's going on in a specific time frame that was anomalous. You want to look for the properties and how did they change over time. For example, you saw an increase of events over time, but then you saw that what really happened there is that specific username was increasing more than the others. So you want to look for the data and the metadata. And you need to utilize both approaches if you want to pinpoint the relevant root cause. So again, just to keep you in context, what we're trying to build here is a software that detects meaningful issues and pinpoint the root cause automatically, okay? So it's a very difficult task to do. Now, after you found, let's say you found out there's something going on, let's say you have a configuration issue, so you detected it, then you can pinpoint the relevant servers that the configuration are errors. Now, the last thing you want to do is you want to fully understand what's going on, and you want to know what to do about it. And for that, you need to apply insight. So this is where it really, we didn't came with a solution that utilize technology here. So we think that in order to really apply knowledge into the problem, you need to use the wisdom of the crowd. So for that, what we do today is that we let customers that already solve the issues to add their own insights, and we use it for all of our customers, and they keep enriching it for us all the time. So we build some kind of a ever-growing knowledge base of the insights that can be distributed back to the customer. So we crowdsource the knowledge model to be continuously maintained by customers, and we moderate it because we found out that many things that they find are not interesting to all of our customers. For example, one of the guys asked, the system asked you, what do you have to do when something like this is happening? And he says, you should contact
John.
Yeah, you should contact the IT division, and he added the number of the telephone number. So I said, okay, that's not interesting as an insight. You want to take it out, you want to moderate it, you want to redistribute it. Okay, that's it. So I just want to give you a few examples of how we apply AI today to the world of IT monitoring, and to build a solution that consists of structuring the data, detect meaningful issues, pinpoint the root cause, and enrich with an insight. Thank you. If you have any questions, I'll be here with John later on.